Okay, Jim Schultz here, back for part two of this time value of money series. We're going to pick up right where we left off, and we're going to dive right into these time value money variables. In part one, we talked about why money now is more valuable than money later. Now we're going to get into a more detailed discussion of the time value of money variables that you are going to see govern every single time value money problem that you will solve in Finance 670, Finance 680, Finance 681, or any other class for that matter, are all going to basically involve the same variables. And here are the variables. Your PV, or your present value. This is basically some money today. Now, you have to be careful here. More so for a class like Finance 680 than what you guys are going to experience in this class. Because and this is going to seem kind of strange, but when you see me work out some problems, it'll make more sense. Most of the time, when you're doing a problem, today is today. But sometimes, within more complicated problems or more sophisticated settings, it actually makes more sense to adjust your present value to make it sometime in the future or sometime in the past. So today, quote unquote, isn't really today, if that makes any sense. And that's the same thing with future value. Future value, by its strict definition, is just some money in the future. Well, that's the case 19 times out of 20, and potentially 20 times out of 20 for you guys. Again, this is a really basic class and a really basic application of these ideas. But I want you guys to at least be aware and be prepared for the fact that there may be times where your future value may actually end up being today. Or your future value may actually end up being, 1 year ago or 2 years ago. And so you just want to be a little bit flexible in your thinking and how you apply these variables. Every time value money problem needs an interest rate. Every time value money problem requires an interest rate. You can think of the interest rate, even if it's 0%, you need to know that. You can think of the interest rate as the bridge that connects the present value and the future value together. It is the glue that's holding together the entire time value of money relationship. In this section, the interest rate may also be referred to as the discount rate. And that is simply because the process of turning future values into present values is literally called discounting. And so sometimes we refer to this interest rate as the discount rate. Interestingly enough, this I that's in the time value of money's application actually has about 4 or 5 different names that it goes by, depending on what context you are in specifically. And we will see that in more detail later on this semester as we go into bond valuation and stock valuation and things like that. Your payment is simply some equal periodic payment over time. So this is nothing more than some equal recurring periodic payment over time. You're getting $100 a month for 3 years. You're getting $100 a year for 5 years. Whatever. You're paying $500 a month for 10 years. Those are all examples of payments that you would put in for your time value of money equation. If you have a sporadic payment, like $40 this month and $80 next month and $100 the next month, that does not belong in this variable. This variable has to be equal and has to be periodic. It has to have both of those characteristics. And then N is nothing more than the number of periods that are in the time value of money problem. So if you're looking at a yearly problem, then it might be 2 years or 3 years or 5 years. If you're looking at a monthly problem, it might be, 10 months or 100 months or 300 months, right? It's simply going to be the number of periods that you are trying to examine. The time value of money formula is basically how these variables all fit together to solve a time value money problem. As you can see, all of the variables are in this formula except for the payment variable, and I'll explain why here in a second. But this is the basic time value money formula that connects present values and future values. So if you have some future value and you're trying to find a present value, you can use this formula. If you have some present value and you're trying to find some future value, you can use this formula. Now, let me be clear because trying to make this equation in Microsoft Word was a little bit tricky. This is the present value is equal to the future value divided by 1 plus I raised to the n. So on the right hand side here, the numerator is future value. The whole denominator is 1 plus I raised to the n. That is the entire denominator on the right hand side. So that is the time value money formula. When you have a payment involved, the time value money formula becomes a lot more complicated. And that's actually beyond the scope of what I'm trying to accomplish in this 5-week class. You'll see that more in a class like 680 or definitely in 681. But we're going to lean on the financial calculator quite a bit in this class. And I've got some videos for you guys on that as well. And so those are, I'm going to wrap up part 2 right there with the time value money variables and the time value money formula. So that's a little bit more about how you directly apply these variables in a time value of money setting. So we'll pick it up with part 3 where we'll wrap this guy up and we'll talk about annuities and how to handle different frequencies.